Hello and welcome to another day, day 4 of the Advent of Code 2021. The problem today, we are going to do part 1, is essentially the bingo. What we do is we are given a file which contains a list of numbers on the first line, numbers between 0 and 100, separated by a comma, and then a list of essentially bingo cards. Every card is based on a 5 by 5 table, and whenever we get a number from the list, they're given in order, we essentially have to mark that value, like here, for example, 4, 11, and 9 are marked. And just like in a bingo, in case you don't know the game, you keep marking values until you find a whole row or a whole column in your table that is marked. When you do, you win the game. So, for example, in this case, this whole row is marked and we won. What the problem is asking us to do is to find which one of the list of cards that we have, or of 5 by 5 tables that we have, will be the first one to win, given the sequence of numbers that we have in the first line. Once we find this card, we have to determine the score. The score is based on the sum of all the numbers that were not marked, so the numbers that didn't come out, multiplied by the number that was the last one to be called when we won. So basically the last number to complete the row or column of this card. So here I already prepared a boilerplate to avoid wasting time. This boilerplate is simply taking the input file, splitting it by lines, and passing it to part 1. Now, what we have to do? First of all, we have to somehow handle the concept of card. So a card, how are they called? I don't remember. Boards. They're called boards. Okay. So what we have to do is to somehow handle the board. Now, this can be done in many ways, but I think a class is the most natural one, since a board is basically a concept which has a set of operations and helpers on it, and boards are completely independent one by other, so we do not have interaction between boards. At this point, I just create a class that I call board, and sorry, parentheses are not really needed in Python 3. First of all, how is it initialized? How do I create a board? I think the most natural way is to pass the complete configuration. So I define the constructor, which is simply the method that is called when the class is created. And the constructor will receive the board table. Let's call it the matrix, because it will be basically a list of lists. Now we have the problem of how to represent this information inside the board. We can keep the matrix as is, so essentially we can create a table of tables. That's how many people would probably do it, because it comes quite natural to think about a board as a matrix, because it's a table essentially. But I find it's not really necessary, because let's think about the operations that we want to do with this matrix. We want to find a specific value that we were given, determine if it's in the matrix and where it is, and we have to keep track of the numbers that we already marked. This operation, this finding operation, suggests to me a dictionary. I think it's easier to handle this problem if we keep a sparse representation of the matrix. It's not really necessary. You can use table as is. It's completely possible, but I think this makes a bit annoying to find values inside it, because we have to do a for, and you have to iterate over all the values, while by using a dictionary, it's immediate to find a value in it. And imagine if this matrix had 1 million elements. If it was 1000 by 1000, you will do on average 500,000 comparison operations to find the value in it. But if you use a dictionary, it's basically immediate, because internally it has an hash table. It's basically jumping to the value all the time. So how do we represent it? I would say that first of all we want to keep track of where a number is. So I say that self.positions is is a dictionary. This dict is completely equivalent to creating an empty dictionary. I just prefer to be explicit like this. Then I want to iterate over all the values in the matrix. So for x in range. No, even better. Let's do an enumerate. So for xi, which is the ix, which is the index of x, or even better, let's call it let's call it x. X in enumerate matrix. Matrix is a list of lists, depending on how we think about it. This could be a row or a column, but I think a row is probably the best way to think about it. So I call it I row, meaning the index of the row, which is 0 to 5. And then I do the same for every element in the column, in the column. So I iterate over the row. So for call in enumerate row. Row is a list. So now call is actually value. I could call it val. Now I have a value, which is the specific number in a specific position. And the position is I row and I call, which is the index of the row and the index of the call. So what I do is I mark the position, self.positions, and this is basically a reverse index of the content of the board, which means that it's already in a it's already a representation that will be useful later when I look for that value, because what I want to do with the board is, given a number, know if the number is in there or not, and where it is. So I already represent the data in this structure. So I say that self.position of val is equal to a tuple, which is I row and I call. So essentially it's a dictionary that says, for example, 57 as a key will be in the row number 2 and the column number 1. Of course we start by 0 because that's Python. So we mark the positions, and that's fine. What else do we need to do with the board? We will need to keep track of which numbers are already marked, so which values are already there, because the board has a state. So as we read the numbers, we will keep track of what has already been marked. Imagine what we see here. We have to keep track of the numbers that are already highlighted. To do that, there are many ways. For example, we can create another dictionary, which, given numbers, tells us gives us a boolean, true or false, depending if it's marked or not. But that's functionally equivalent to a set. So I can just say that self.marked is an empty set. So every time I see a value, I can mark it. Then what I want to do is to just go through the exercise and build the boards. So first of all, in the part 1 I receive an array, a list of lines, and I know that the first line is just a list of the numbers that I will have to mark. So how can I call it? I think there is a specific word that we use in the value, drawn. Yes, okay, that's specific for this. So drawn numbers is equal to lines 0. So the first, what happened to my keyboard? Okay, lines 0, but what, split by comma, and then while at it, since those values are actually numbers, I have to I have to create int n for n in line. So I simply convert them to actual numbers, not string that represents numbers, and store them in raw numbers, which will be useful later. Now I have to essentially go through the list of the lines, which is this huge list, and generate the boards. So how do I do it? There are many ways. I will simply split the remaining lines in group of fives. So I simply go 5 by 5. Here we have a problem, however, which is that we have empty lines, and I want to completely ignore them. So what I can do, since I do not care at all in the whole problem about these lines, I can directly in the main get rid of them. So here, when I split the lines, I simply say, okay, keep the lines, so L for L in the splitter lines. This is completely equivalent, it's not doing anything. I go to the new line so it's a bit more readable. I say, okay, lines is not anymore just the list of the lines, but is only the list of lines where L dot strip, we already saw strip in the previous exercises, is removing empty space at the beginning of n, is different than the empty string. So essentially we say, okay, keep only the lines that actually contain something. If they contain empty spaces or some garbage, just ignore them. So lines is now in theory containing only the list of the draw numbers and the rows in here that contain some data. Now in part 1, so draw numbers is the same because the first line was already valid, so we just keep it as is. The second, third, fourth and so on lines will contain the boards. I want to be extra sure because it's very tricky when you process files with this text format that there is some weird thing like empty lines that you miss. So I put an assertion. I assert that len of lines minus 1, because the first one contains the numbers, divided by 5, modulo 5 is equal to 0, which means, okay, take the amount of values, remove 1 because we know that the first line is actually the list of numbers, so it's not a board. The rest should be an exact multiple of 5. Spurious data. This assert is simply asserting exactly, so declaring that this statement is true, and this string is simply something that will be shown to the user if this data is this assertion is not respected. So I run the exercise so far, date 04, and it's working. So the data is in fact multiple of 5. So we have all data we need. Now we want to iterate over these lines. How do I do that? I can use simply a for cycle for b, let's call it b pos, mean the position of the board in the list of lines, in range that goes from 1, because I want to skip the first one, to the length of lines, because I want to skip, I want to go reach the complete end of the lines, and I have the third parameter, which is 5, which is the step. So essentially I'm saying, okay, start from 1 and grow of 5 every time until you reach the end of the lines. So what I do now is I get the matrix. So the matrix is equal to a list, because I have all the rows. So I have a row. Oh, what? So I have a row for well, let's see, for row in lines that goes from the b pos, which is the start of this matrix, to the end of this, which is b pos plus 5. Usually you would want this 5 number, which appears many times, to be a constant. In fact, we can just put it here. Sides, let's call it board sides. This is some mistake. Is equal to 5. This makes clear that this 5 is not a magic number, but is in fact the size of the board. I put it here and here and here. I use black to format. This is just for my convenience. So essentially, I have in my project, which you can see on GitHub, a makefile, which is simply a useful way to. It does many things, but in this case, it's just a way to store commands with a name and call them in an intuitive way. And I have a command which is format, which is invoking black, which is a code formatter, which simply rearranges my code in a nicer way. I think in this case it's not very nice because actually I am going to expand this row. So matrix in this case is a list of rows, but I do not want the row as it is now, because row is just a line of the file. I want actual numbers. So what I do is say, okay, for each row, and sorry, black really didn't help in this case, I want to split it. I want to split by spaces, which is the default behavior. Also notice that if you have two spaces like here, split without any parameter will also take care of them, so I will get the list of numbers. But after splitting, I also want to transform them into actual numbers, not strings representing numbers. So I say int c for the in row split. So basically, I'm iterating over the rows in the matrix, and for every row, I'm splitting it by spaces and getting this list of values. And that's it. So I have now a matrix. I think I want to display it. I want to see what is here the result of the content of the matrix. So I say, okay, print matrix and the matrix value. I just want to print to a screen so they can run and see what happens. That's very interesting. It's not actually running. This is day 4, right? Interesting, very interesting. So this is day 4 and is not doing anything. Why? So at some point this is breaking. Okay, so maybe it's the amount of... We have to find where it breaks. So first let's see that it actually is retrieving the lines. So I say print lines, running it. Interesting. Again the same error the other day. Stupid error. Okay, so I didn't need to do more debugging. I think this was the problem. Okay, so let's check a few things. So we see that it's generating matrices, and these matrices contain 1, 2, 3, 4, 5 elements for 1, 2, 3, 4, 5 rows. So it's working as expected. Let's check that the last value is complete. So I want to check that the last board, this one, 1947, blah, blah, is there. How can we ensure that in the code? We can say that the amount of words is equal to the amount of lines minus 1 divided by 5. So, okay, we get a matrix, but we do not want to actually keep the matrix. I want to keep the boards. So before the for, I say that boards is an empty list, and in the for, I say that to the boards I want to append a board initialized with this matrix. So I'm simply creating an instance of the class board that I simply created just before this, and storing it in my list of boards, initializing it to the content of the matrix. The board internally will keep track of everything related to a specific board. And now, after I did it, I just want to be sure that the amount of boards is correct. So I say assert length of lines minus 1 divided by 5 is equal to, this is, here I need parentheses because of the priorities, and I think it's better to put parentheses just in doubt to make it clear, is equal to the length of boards. So I run it again and I shouldn't get any error. Perfect. So this none is because I'm printing yet the result of this function, but this function is not actually finishing. Very nice. So now I have all the boards I need. What I have to do is to, in fact, mark now the values and look for the first board that is going to win. So what I want to do now is to go through the draw numbers and one by one mark the board with them and check whether I won. So I want to stop as soon as I find a board that won. So what I do is I go for the draw numbers, called dn, in draw numbers, and for each one of them I want to mark all the boards. So I want to tell the boards, hey, keep track of this number that was drawn. This means that the boards have a state, but I'm completely fine with that. That's, I think, a correct representation. So I'm completely fine with the fact that the boards have a state. Then I go to the boards for b in boards. I want to do b dot mark dn. What is mark is something that we're going to define now. I define a mark operation which simply gets a number and marks it. What does it mean marking it? It means first check whether this number is on the board or not. And this is simple. We designed the representation inside the board specifically to allow for this operation. So I check that if self.positions if the number is in the positions, which means that if there is a key that is in there, what I do, I say that okay, self.market is equal, dot add, because market is a set of the positions are market, so the coordinates of the market columns. What do I add? The position of its own value, self.position number. Notice that in a bingo board, a number can appear only once. So there is only one position in which this number is. If it wasn't, we would need to store not just a tuple. So here we wouldn't store just tuple, but a list of tuples. But this is not the case because it's just the way bingo works. And that's it. I'm only marking the value. I'm not doing anything but checking if the number is there, and if it's there, what is its position. So just taking note of the fact that this number was found. And now we have to do what? We have to check if a board won after marking a number, and if it won, what is the score? This can be done in a single step, so I just say after determining a number and after assigning it to all the boards, after marking it on all the boards, I again iterate over the boards another time, and this time I want to check if the board is winning. So let's say that a board has also a method to calculate its winning score, so it already gives me essentially the solution. And to do that, just give me the sum of a market. Let's say that we want to find out. Let's create two methods, so it's a bit simpler to follow. So first I say, okay, if a board is winning, then I want to get the unmarked. So b dot get unmarked, which would be a set of the numbers that are not marked as winning. So I do the sum of this multiplied by the value that just won, which we know because it's the n. And I return it. So what I do is I need to create two methods, which are isWinning, which simply tells me if the board is winning, doesn't matter how, if there is a column or a row that are completely marked. And then we need another method in the board which gives me the list or the set, doesn't matter, some iterable, of all the numbers that are not marked. Let's start by defining the winning functionality. So here I have def is winning self, and that's it. There is no other condition. This will return a boolean. I think it's not needed to specify it here. How do I determine whether a board is winning? Well, we have the market set. So what I want to do is to count how many rows and columns, how many values are marked as in every row and column. So I create a counter. So row count is equal to the number 0, and a list containing number 0 multiplied by both sides. Both sides actually with a single element, and the same for the column count. This is just the sum of market values, the count of market values for each row and column. Initially it's 0 because I still didn't do anything. And then I say, okay, for rc in self.market. So I say, okay, go to the list of market positions, and for each one give me the row and column that are in that position, and I increase the corresponding counter for, so I say row count at position r plus equal 1, and the same for the column. So column count, of course, this not r but c. So essentially I'm taking the sum, actually the count of market position across rows and columns. And when do I win? If any of the values in the row count or column count is equal to 5. So essentially, if there is at least one row or one column when everything is marked. So any r in row count. What I want to do is r equal to board size, so rc for row count equal to board size for rc in row count. So say, okay, if any of these is equal to 5 in our case, or any of the column count for column count in I have to add some parentheses because Python doesn't like it, of course. So I'm simply putting as a condition that this oh, that's ugly. I don't like it. No, okay, doesn't matter. So I'm simply putting as a condition that either one of the row count or one of the column count is equal to the board size, which means that it's complete. And that's it. So let's try to already detect when there is a win. So I say, okay, let's try to print, first of all, the numbers that are drawn. So I say print the n, and then I want to print when a board is winning. So I say print b, and that's it. So this will break because there is no get on market yet, but will at least print the first winning board. So I can check that the code written so far is correct. And in fact it's not, because there is a small typo here. I have positions, it's not position. I run again. Okay, now it's complaining that the board has no get on market, which is correct, we didn't define it yet. But we already find that we had a winner at some point. But when we print it, we do not get anything nice. Why? Because when we print an instance of a class that we created, Python doesn't know what to actually print, so it just prints this sort of default representation of a class. We can do something nice, and we can say, okay, let's define a str method, which is what is being invoked by Python when um, when a print or any string representation is necessary, and this time I return a string representation of the matrix, which are without much effort for formatting. Sorry, there is no string representation of the matrix. It's a positions dictionary, so self.positions. And also let's say that I want to return the market values. So I say market is, let's use an f string. So f, it's much easier to read. So I use an f string, I say those are the position, and this is what is market, so self.market. And okay, let's run again. Okay, nice. So let's see what we got here. We got a board that, for example, has 78 in position 00, 80 in position 01, and so on, and has already a few market values. Let's check that these values form a winning board. So, for example, I can see that I can already see that the column a position 4 tends to appear many times. 2, 3, 4, 5. Yes. So the column 4 is winning. Perfect. Let's see that this board actually exists. So, for example, we have at position 4, 4, what do we have? We had 99. Is 99 here? Yes, in fact, is the last value to appear. So this seems to be working. At least I don't see any obvious error. Fine, that's very nice. So we can go on. We remove this print that we're here for debugging, and I get the unmarked values. This is quite trivial to do because I say def unmarked. I of course already forget what get unmarked. Unmarked self. What does it do? It goes through all the elements in the positions. So for what is the number and row and column in positions.items. So it's simply basically enumerating the positions, self.positions. And this is called unpacking. So essentially items gives me key, a tuple with key and value, but the value in this case is also a tuple with row and column. So with this parenthesis, I ask Python to match this tuple that contains tuples itself, and give me all the values already explicitly represented. So for this position, actually it's not needed because the coordinate is already what I use as a wall. I say that what I want to do is I want to say that if the coordinate, what was the name, self.market dot has if the coordinate is not in self-market, so if it's not one of the coordinates already marked, I want to return n. Wait a moment, I want to return n. I want to return all n's that match this thing. So I return a list of n for n in this thing if this condition is true. So I'm just doing a list comprehension. It's a bit simpler to read, so I just say, okay, give me every n for n coord in self position, so go through all the positions and give me only the positions that are not marked, and that's it. This should already return a value 89001. This should be, if there are no mistakes, the solution to this puzzle. Great. See you for the next part.